Alright, should be lesson 4.1 because this is unit 4, lesson 1. The reason why I said 6.1 before is because it's out of chapter 6 of the book. But unit 4, lesson 1, solving one-step linear inequalities. Okay, so now instead of solving equations, we're going to solve us some inequalities, or some of those things that are not necessarily equal. So your objectives are to graph linear inequalities in one variable and to solve one-step linear inequalities. Let's hop to it. Okay, here's a word problem. Seth is sure that he didn't score less than a 77 on the Chapter 3 algebra test. Write an inequality to describe Seth's possible score, then graph. Okay? So, step 1 is to write an inequality representing the situation. So, it says Seth is sure that he didn't score less than. Okay, so he couldn't have less than a 77. That does mean he could have a 77. Okay, so pretty much Seth is saying he's absolutely sure he didn't fail, or he didn't get less than a D on the test. Okay, less than a 77%. So he could have gotten a 77. So Seth's score is something we don't know. Okay, so we're going to say that Seth's score is X, and it's got to be bigger than or equal to 77. Okay, there's our inequality. Seth's score is greater than or equal to 77. Next is to make a number line. Okay? So your number line needs to include numbers around 77. Okay? Including 77 itself. Well, I'm going to go ahead. I always like putting my number in the middle. And I'm just going to put a couple numbers on either side. So here's 78 and 79. And here's 76 and 75. Okay, now this is the graphing part. So we already wrote our inequality. Now we're graphing it. Okay. Step 3 is to put a correct dot at the location of the number. So at 77, I need to put a correct dot. Now we need to know about our dots. First of all, I've got two types of dots. One of which is a closed dot, and one of which is an open dot. Okay, and now actually let me erase this really fast. Okay, I'm going to go ahead and put up here types of dots. Okay, and we've got a closed dot or an open dot. Closed dot looks like this, and it is used when we have a greater than, First of all, let's talk about what a closed dot means. A closed dot means the answer is included, okay, or the number that your dot is on is included. So that means if I put a closed dot on 77 here, 77 has to be a solution of this. Okay? Well, that makes sense for two types of inequalities, greater than or equal to, or less than or equal to. Because the or equal to tells us that this number is included. An open dot is for less than or greater than. Okay? Because that number isn't included. If this just said greater than 77, then 77 doesn't work. So I would put an open dot on that. So put the correct dot at the location. Because this says greater than or equal to, I'm going to put a closed dot here on 77. Okay? And now the last thing I need to do is I need to shade toward numbers that make the inequality true. So, out of the numbers I wrote down here, I need to decide what numbers make this true. Well, I know that 78 and 79 are both bigger than 77, so I'm going to shade toward them. Shade toward those numbers, including this arrow, because that arrow tells me that that includes all numbers going that direction. So I've got my closed dot, and I've got my shading. So this graph says that all numbers, including 77 and bigger than 77, work for this inequality. Alright, let's go on to another example. Okay, now I've got two examples here of solving inequalities with the proofs. So it says to solve the inequality is the same way you solved equations, if they're addition and subtraction ones. So this one says x plus 5 is greater than or equal to 3. Well, first I would change to addition if I needed to, but it's already addition. So I'm going to do a -5 to both sides. These cancel, and I get x. Now this is where it changes. I'm going to keep my sign, greater than or equal to. And 3 minus 5, or 3 plus negative 5, is negative 2. And my proof, of course, is subtraction property of equality. Now if they told me to graph this, okay, here's my answer, then I could graph it too. I'd make a number line. I'd put negative 2 right here, and then negative 1 and 0, and then negative 3 and negative 4. Think to yourself, open dot or closed dot? Well, I'm going to need a closed dot because it's got the or equal to. And now, don't get in a habit of picking which way this goes, okay? Meaning some of you are going to say, oh, this says greater than or equal to, so it goes to the right. Just don't think of it like that. Think of it as what numbers satisfy the inequality. So this says the numbers I shade have to be bigger than negative 2. So I'm going to shade toward numbers bigger than negative 2. That's negative 1 and 0. So there's my graph if I needed it. Alright, let's go on to this next example. Well, first thing I should do here is change this to addition. So change to addition. Now I'm going to add 4 to both sides. This cancels. And negative 2 plus 4 is 2. And keep your sign the same. Okay? And that was addition property of equality. Now I can leave this like this. Okay? Before, Mr. Ayers said he always wants a variable on the left side. For inequalities, you can flip it around, okay? But I want to show you for the purpose of graphing this here, okay? I want to leave it like this for now, just to show you. So if I put 2 here, and 3 and 4, and then 1 and 0. Well, first thing is I need an open dot because it's just a greater than. 2 is not a solution of this. Now I need to shade toward numbers that make the inequality true. This says 2 is greater than the numbers I shade. So that's what I'm talking about. Don't get used to seeing the sign and thinking, oh, it's greater than, I'm going to shade to the right. This says 2 is bigger than the numbers I shade. So the numbers that satisfy that are over this way. Okay? Because 2 is bigger than those numbers. So what you could notice from that is that if I wanted to rewrite this inequality with my variable on the left, I switched the variable and the number around. So what happened to the sign? Well, this says that the place I shaded, look at this, the numbers I shaded here are less than 2. So the sign has to flip as well if I'm going to write it like this. So we can write this either way. Okay? Alright, let's go on to multiplication and division examples. Now, rules for solving multiplication and division inequalities, okay? This is like solving equations like you've done before, but there are a couple rules you have to keep in mind that are very important, okay? If you multiply or divide by the same positive number on each side, you keep the inequality symbol the same. So when I do the property of equality, if it's the same positive number on both sides, I keep the inequality symbol looking the same. If I multiply or divide by the same negative number on both sides, I have to flip the inequality symbol or reverse it. Alright, let's take a look at what Mr. Ayers is talking about here. There's 2 different examples with proofs. Okay? This first one says x divided by 2 is greater than 8. So I'm going to solve this like normal. The only thing I have to do is multiply by 2 on both sides. This is the multiplication property of equality. Alright? Well, when I do the multiplication property of equality, now look. Okay? I'm going to get x, and 8 times 2 is 16. Now I have to decide, did I multiply and divide by the same positive or negative number on both sides? Well, I multiplied by a positive on both sides. My work I did was a positive on both sides. So this sign stays the same. So it's x is greater than 16. Okay? Well, that should make sense, because let's pick a number that's greater than 16 and plug it into this. Let's say I pick 18. 18 divided by 2 is 9. That is greater than 8. Okay? If I flipped the sign and said it was less than, say I picked 14. 14 divided by 2 is not greater than 8. So this works if I put in examples for it. Well, this one over here, I'm going to divide on both sides by -5. And we're going to have a division property of equality. Okay? Well, again, look at what I'm dividing by on both sides. I'm dividing by a -5 on both sides. So I'm going to get x, and 45 divided by -5 is -9. But I divided by a negative on both sides, so I reverse the inequality symbol, meaning I take it and flip it around. So to make this true, I have to have numbers that are bigger than or equal to -9. Well, let's check that. A number that's bigger than -9 is -8. Okay? If I took -5 times -8, that is 40. And 40 is less than or equal to 45. So it works. Okay? So keep these rules in mind, and remember, you have to know when to flip the symbol and when to not flip the symbol. Okay? That's very important. And you won't get to use your notes on that for the test. So make sure you study that and know it. Okay, good luck on your homework. Ask questions if you got them.